This one. Sheila. Should it? Okay. That's one. Okay. Chat. Let me keep it here. If you want to follow the writing, you can check the chat.
Okay.
Yeah, they will write something. Yeah.
If I want to chat them up,
if they want to chat you,
okay.
they will write here because they are not. They can't speak. Okay. If you want to allow somebody to speak, you unmute here like this.
Okay.
Mute. There's no screen. You can check. Okay. And this way you can allow them to speak. And they can see your screen wherever. You can start. When you go to front, just this one. For next step, next slide.
Okay, next slide.
Yeah. Make it from here.
Okay, I can do this.
Şey koyduk üzerine. Okay.
You want to move to next slide? I can do this.
Click on bunu deneyin abi. Ama click yapmazsan geçmez. Tamam. Okay. Click is better. Okay. Let's start.
Good day, everyone. Welcome you all to this meeting. If I would like to know those that are online, I wanted to indicate, signify your presence by raising up your hand. I want to know those that are online. Sunny, I can see you, Sunny. I can see Afisa. I can see Sumaya Mustafa. Any other person online? Ismail? Halima Uma. That's good. How are you? Okay. Who else do you have on the platform? Before we begin the class. Okay. The others will join us as time goes on. So far so good. We have discussed a multiple series of the arcanes and arcanes as well as arcanos. So we're about to begin this topic before we went on break. So today we shall continue from here. As you can see on the screen, what is displayed there is stoichiometry. Say it after me, stoichiometry. That is the correct pronunciation of the topic. Before we delve into the topic proper, I would like to relate everyday activities that involve stoichiometry. I want to understand the fact that some of these products you use every day, such as soap, perfume, fertilizer, gasoline, and all sorts of industrial products, they were made based on stoichiometry. Likewise, a farmer that wants to add fertilizer to his farmland, you need to think of how much of the fertilizer he needs to add to. So that is stoichiometry too. Likewise, everybody cooks. In the kitchen, if you want to cook whatever you want to cook, you bring the ingredients together, and the ingredients must be made in certain proportions. So a calculated amount of each of the ingredients must be added, because if you add in excess, it will affect the taste of whatever you cook. So that's also stoichiometry. So, but stoichiometry to a chemist. What is stoichiometry as far as chemistry is concerned? Stoichiometry from the perspective of chemistry. The structure is equally called Maxwell relationship and reactions. So these are the subtopics we'll be looking at as far as this topic is concerned. The meaning of stoichiometry, the new concept, solving mathematical problems related to stoichiometry, limiting of excess reactants and reagents, percentages and theoretically. We will not be able to finish all this today, but wherever we stop, we continue from there next class. To start with, what is stoichiometry? As you can see on the screen, the meaning of stoichiometry, or the word stoichiometry, comes from the Greek words. Two Greek words. The first one being stoichion and the second being metron. And the meaning of each of the Greek words were given. So stoichion means the element and metron means what? Measure. So from this, we can literally define stoichiometry as the study of measurement of elements. The elements they are referring to here really has to do with the particles in matter. Remember in the SS1, under particular nature of matter, it was mentioned that the particles in matter can either be atoms, molecules, or ions. For example, if I pick a substance now, for example, gold. Gold is made up of atoms, gold atoms. Likewise, if I pick another substance, for example, water. Water is made up of what? Water molecules. Likewise, the table salt we take at home, if you look into the composition of it, you find out that it's made up of ions. Meaning, these are the various particles you can have, depending on the substance and the type of particle that they are in. So, with what I've just explained now, we can redefine stoichiometry as what? The measurement of elementary units or the particles in matter. Okay. It actually deals with, it doesn't stop there. We look at it from a broader perspective. Stoichiometry deals with chemical calculations. So we're going to calculate in a great deal in this very topic. And this calculation is based on the elementary particles of the matter that we just mentioned now, atom, molecules, or ions. And as well as the quantitative relationship between reactants and products in chemical reaction. So from this, we'll observe that the first statement here says stoichiometry deals with chemical calculations and elementary particles. This is one type of stoichiometry. The second part of stoichiometry is when you determine the quantitative relationship implied by chemical reaction. The quantitative relationship between atoms and chemical reaction. That leads to two types of stoichiometry. So you have two types of stoichiometry as you can see on the screen. First one being stoichiometry of composition and stoichiometry of chemical reaction. I forgot to tell you, for those that are just joining, that you need calculator for this part of exercise. You need calculator beside you because you're going to do some calculations. I want to believe you have it already. If you have your calculator with you, signify. Let me see your hands. Just make it flash like this. Raise your hand and indicate. Let me see those that have. Okay. 3. If you don't have the calculator, you can go back and pick it up because they're going to be doing the calculation together. Really. So let's proceed. We've identified the two types of stoichiometry. The first one being what? Stoichiometry of composition, and the second one being stoichiometry of chemical reaction. So the calculation we're going to do today will be on stoichiometry of composition, and subsequent class we're going to look at the stoichiometry of chemical reaction. Now, the two stoichiometry, because they are involves chemical calculation. Calculation is based on mole concept. The basic idea used is solving stoichiometric equivalent mole concept. And I want to believe that this mole concept you're looking at is not new to your brain. You must have done something related to it in your research. Mole concept. So we're going to look into mole concept since it is the concept we're going to be using to do our calculations. So we need to review some of those things we have done as far as the concept is concerned. How we are following. So look at mole concept. The word mole concept. This mole concept is a unit adopted by chemists to describe the quantity of elementary particles in matter. Because the elementary particles in matter, they are so tiny and they are so numerous. So chemists adopted a system that can make it easy for them to determine the elementary particles in matter. Remember, when we define stoichiometry, we mentioned the fact that it deals with what? Chemical calculation based on the elementary particles in matter, substance. Well, this word mole is very similar to the everyday terminology normally use. And what is that term? Dozen. I say a dozen. A dozen is made up of what? 12 units. Okay. So mole is similar to a dozen, only that the unit in the mole is much more than that of a dozen. So if I ask you a dozen of donuts, how many items are in a dozen of donuts? Yes. That's 12 donuts. Likewise, mole, if 12 units is what we have in a dozen, a mole contains Avogadro's number of particles, which is 6.0. So if I say a mole of donut now, how many 1 mole of donuts will contain how many donuts? 6.0 donuts. So what you really need to understand here is that 1 mole of any chemical substance, regardless of the component of the substance, 1 mole of it will contain 6.0. I remember we mentioned the fact that particles in matter can either be atomic. So if I pick atoms now, atoms, they are the smallest unit of element. We are talking of atom of what element should come to mind. So, and we all know that elements are the building unit of matter, made up of atoms, and we have about 118 of them. So the first one, hydrogen, helium, till the 118th number. So each of these elements is symbolized or represented by symbols. So each symbol represents atom of the element. So if I say 1 mole of carbon element now, C, 1 mole of C is represent carbon. So in 1 mole of carbon, how many atoms are we going to have, or how many carbon atoms are we going to have in 1 mole of carbon? Remember we said 1 mole of any substance contains 6.0. So 1 mole of carbon atom will contain 6.0 atoms. Okay. Particles can also be molecules. So H2O here is 1 mole of H2O. It's 1 H2O, 1 mole of H2O. We call it contains 6.0 water molecules. Likewise, we have another 1 mole of sodium chloride. We contain what? 6.02 sodium ions. So the most important thing you need to learn here is that 1 mole of whatever, be it an atom, molecule, or whatever it is, will contain 6.02 particles. Likewise, for you to understand this was a building. You can see on screen. This is 1 mole of iron atoms. How many atoms will be in 1 mole of iron atoms? It will be what? 6.02. If you can see the very big figure we have here, 602 about 21 zeros iron atoms. It means 602 hexillion. So the 602 hexillion was abbreviated to 6.02 times 10^3. So 1 mole of iron atom will contain 602 hexillion iron atoms. Or you see 1 mole of iron contains 6.02 times 10^3. If you have 1 mole of people, how many people are there in 1 mole? 6.02 times 10^3 hexillion people. If you have 1 mole of apple, how many apples do you have in 1 mole? 6.02 times 10^3 or 602 hexillion apples. Okay. Take note of the fact that this big number you are seeing was abbreviated to 6.02 times 10^3. It was put in standard form. The application in standard form, you don't need to use 6.02. So the most important point here is that 1 mole of anything, be it an atom, molecule, or whatever, contains 6.02 times 10^3 particles. Are we following? So we move on. It's just a quiz to examine you on what we have said before concerning mole of the number of particles we have in 1 mole. So if you look at this question, how many particles, specifically atoms? Particle can be atom and molecule. It depends on the substance. So the substance there is sodium, and sodium is an element. And the tiny particles of sodium atoms. How many particles I can see? How many atoms are there in 2.5 moles of sodium? You can tell us that. Just let me see. Just can type it and let me see what you're going to do. How many atoms are in 2.5 moles of sodium? Yes. The response. Anybody? Just calculate it and tell me. You can type it and let me see. Yes. The hint here is that if 1 mole of sodium is this, 1 mole of sodium will contain 600 times 3. How many atoms will be in? Very good. That's good. That's good. So that means 2.5 in 2.5. If 1 mole of sodium is 6.0 times 10^3, 2.5 moles will be what? 2.5 times 6.0 times 10^3. Yes. Okay. 1.505. That's from that 1.505. Then from this, I want you to make use of your name, your real name, so that I can. So from that point, it is 1.505 times 10^24. Well, then what about the second one? How many particles, specifically molecules, are in 0.05 moles of water? Water contains water molecule, H2 molecule. So how many molecules of water do we have in 0.05 moles? Bearing in mind that 1 mole of water contains 6.02. So if 1 mole of water molecule is 6.02 molecule, 6.0 times 10^3 molecules, 0.05 moles will be what? Yes. That will be what? 0.05 times 6.02 times 10^3. Press the calculator and let me see. I want your response here. Yes. Anybody? Correct. That shows we are following. We move on. So another concept you need to understand here is molar mass. All this is I'm talking about right now. I am not need to learn this concept before. This is more like a revision, because this is what we need to do our calculation with the geometry. So molar mass, as it is being displayed on the screen. What is molar mass? What is molar mass? As you can see on the screen, molar mass, from the word molar mass, that is mass of 1 mole of any substance. Mass of 1 mole of any substance. mass of 1 mole. And in 1 mole, how many particles, how many substances do you have in 1 mole of a substance? That's 6.02. So if 1 mole of a substance containing 6.02 times 6.3, so if you have to measure this on a chemical balance, it will give you what? The molar mass of the substance. Now, a specific substance was given, 1 mole of sodium